Okay, here's a past paper on parametric volumes of revolution, split into two parts. So you're given a curve, it's called C, and it's got this equation, x, y, both in terms of theta. Then we've also got this straight line L. We know it's a normal to the curve at the point 3, 2. And we're also told that theta only has a value between 0 and pi by 2. So there's two parts to this question. Part A is worth 6 marks. We need to find the x coordinate of Q. This is actually the harder part of the question, I would argue. Part B is worth a lot more marks, and it's the volumes of revolution. 9 marks here. I think we can pick up all 15. So let's dive in. First of all, I want to find the x coordinate of this point Q. It is on the line. So I'm going to use my general equation for a straight line. Y minus y1 is equal to mx minus x1. I've got coordinates. I know this point 3, 2 is on my line, but I don't know the gradients. So I need to work out a way of finding the gradient of this line. We've been told it's a normal, so let's work out the gradient of the curve. I've got the equation of the curve, so I need to work out what is dy by dx. So for my curve, I know that x is 3 tan theta. My y is 4 cos squared theta. So to work out dy by dx, first of all I will differentiate each of these separately. Remember, if you differentiate tan, you get sec squared. And then I'll differentiate my y. So bring down the 2 will give me 8 cos theta. And if I differentiate the cos, I will get minus sine. So overall, I'm getting minus 8 cos theta sine theta. Well, I don't want the theta in my equation, so I'm going to use the chain rule. I want to work out dy by dx. So to get there, I will use my dy by d theta. I want the y on top, don't want that theta. So I'll need to multiply it by a d theta on the top, so they cancel, dx. Now that is just 1 over this, so I'm doing the reciprocal. So my dy by dx is minus 8 cos theta sine theta times by 1 over 3 sec squared theta. Now recall sec, that's 1 over cos, so 1 over sec squared is just cos squared. So I have a cos theta here, I will have a cos squared theta here. Overall, this will give me minus 8/3 cos cubed theta sine theta. Okay, so that is my general gradient of that curve. I want it at a specific point though. I'm interested at the gradient here. So my x coordinate is 3, my y coordinate is 2. My gradient, however, is given in terms of theta, so I'd better work out what theta is. To do that, I'm just going to go back to this equation. It's probably the easy one to use. X is 3 tan theta. And let's work out our value of theta. So at x equals 3, I'll have 3 is equal to 3 tan theta. In other words, my tan theta is equal to 1. You can either remember that value or put it in a calculator. You'll get an answer out of pi by 4. That is the only answer within the range. 0 is less than or equal to theta, which is less than pi by 2. Okay, so at theta equals pi by 4, my dy by dx, you can just put this straight into your calculator. If you know your exact values, you wouldn't need a calculator to do it, but you've always got one of these in your A-level maths exams, so let's just put it in. You should get an answer out of minus 2/3. So the gradient of this curve here is minus 2/3. We want the gradient of the normal. So our normal gradient is minus 1 over that. We'll get 3/2. You've done all your hard work now. We just need to use this equation. So y minus, we've got our coordinate 3, 2. So y minus 2 is equal to mx minus x1. Right, I'm going to multiply everything by 2, just to get rid of this fraction. That'll give me 2y minus 4 is, and I'm going to multiply out this bracket, I'm multiplying it by 3. So 3x minus 9. Okay, that's the equation of my line. Now, where do I specifically care about? I care about my x coordinate of q. Well, what's my y coordinate of q? It's just 0. So when y equals 0, we're on the x-axis. So I'll get minus 4 is 3x minus 9. It's the same as saying 5 is equal to 3x. Or x is equal to 5/3. That is your answer to part A. So say I would argue that as the harder part of the question. Might just make a note of it on my diagram. Point here, oops, sorry, get this right around, is 5/3, 0. Lovely. Okay, part B, we're going to take this region and we're going to rotate it 2 pi radians around the x-axis. I want to find the exact volume. To do that, I'm going to need to separate this into 2 sections. As I could rotate this whole area under the curve up to this point here. I know its x-coordinate is 3. And then just subtract this part, which I don't want. That's a triangle. When we rotate a triangle around an axis, 2 pi radians, we will get a cone. So this will give me the volume of the cone, and I'll need to subtract that from my whole volume under that curve. So for now, I'll just call that area A. The first one I'm going to work out is everything underneath this axis up to there. So all of that area rotated round. And let's see what we will get. We'll go to our equation for the volume of revolution parametrically. So the volume is equal to pi between, so this will be x equals 3 and x equals 0. I'm going to have to change those limits. But it will be of y squared dx by d theta. Notice I'm using theta rather than t. That is just because theta is my parameter, not t. Okay, let's start putting some of these in then. We've already done dx by d theta. We did that in the last question. We got 3 sec squared theta. So that's handy. Let me make a note of that. We don't need to do that again. Y squared, well, I know what y is. Y is 4 cos squared theta. So if I square that, I'll get 16 cos to the power 4 theta. Then I need to replace my limits. So go back to what x is. X is equal to 3 tan theta. If x equals 0, that's my bottom limit, I will get 0 equals 3 tan theta. In other words, tan theta equals 0. Check it out, you'll also get theta is 0. If x equals 3 in this equation, I get 3 is 3 tan theta. In other words, tan theta is equal to 1. That also gives me quite a nice value. I'll get theta is equal to pi by 4. And actually, we had already worked this one out in the previous question. So I've got my new limits. From here, it's just standard integration. So I'm going to replace my limits. These are in terms of theta now. I've got y squared, that's 16 cos to the power 4 theta. And I've got my dx by d theta, 3 sec squared theta, d theta. Some nice cancelling happens here. This, remember, is 1 over cos squared theta. So overall, I'm going to have cos squared theta, and then I need to do the 16 times 3. Well, 16 times 3, that gives me 48. And I'm just left with cos squared. Okay, you should know how to integrate this, but we'll do it. I'll remind you. Even powers of cos, we need to use the double angle formula. So our double angle formula, what does it tell us? Cos squared theta is a half cos of 2 theta plus a half d theta. So remember, that is in your formula book, but you need to just be familiar with using that. You'll always use that for even powers of cos. I've got half in both of these, so I'm going to take that outside of the bracket. It will give me 24. And that 24, I might just write outside of my integral for now, as it's a constant. I can do it. And I'm left with integrating cos 2 theta and 1. Both of those are straightforward to integrate. So we'll get 24 pi. Okay, cos, I better get sine 2 theta. And I'll check this. If I differentiate it, I get 2 cos 2 theta. I don't want the 2. So I'll put a half in front. Integrate 1 will just give me theta. Now we'll put our limits in. Just noticed already, if I put 0 in as a limit, sine of 0 is 0, and this will give me nothing. So the second limit doesn't actually do anything. It's only the first one which will matter. And I end up getting 24 pi a half plus pi by 4. And that is 12 pi plus 6 pi squared. Right, you've done all the hard work now. The last bit will come out pretty quickly. I know this whole area integrated, done as a volume, gives me that answer. I don't want this cone. So I'm going to get rid of this cone now. So recall, the volume of a cone is equal to 1/3 pi r squared h. Okay. So 1/3 pi times my radius. When this becomes a 3D shape, this will be my radius. That's my y value of 2. Times by, what would the height of this cone be? This will be the height of the cone. So I'm going between x is 3 and x is 5/3. For 3 minus 5/3 gives me 4/3. So 4/3 is my height. And when you put all of that together, you'll get 16/9 pi. That's the cone. So I don't want that cone. So I've got all of that. Take away this for my final volume. So my total volume, 12 pi plus 6 pi squared. Take away the 16/9 pi. When you do that, you'll get an exact answer of 92/9 pi plus 6 pi squared. And that's it for 15 marks on that question.